Okay, so we're working on the practice test for systems of equations. All right, the practice exam document. I'll pull it up so you can see it. So we're talking about this one right here. Okay, systems of equations, practice exam. To begin this lecture, let's just start off looking at the problem. Okay, 1, 2, and 3 ask us to solve each system using substitution. We have to use this method. We can't use another one. Okay, elimination is going to be for problems 4, 5, 6, and 7. So we need to use substitution. We can't pick another method. We can't just do whatever we want. So if we look at substitution, we can see that the steps for substitution were right here. This idea of isolating a variable, substituting to the other equation, distributive property. All these ideas are very important, and we've covered them for a while. Okay? So just understand step 1 is isolate the variable. Let's go try to do that step for the first problem. Okay? What that means is that I want to get one of these letters, okay, because a variable is just a letter, so I want to get one of these letters by themselves, okay? However, both of them are already by themselves. So in this case, we would say that the y is isolated. It's already isolated. So that means that step 1 is done for us, and that's why this is the easiest kind of problem, because that step is already done. Okay, so step 1 doesn't really take much effort. We're just going to go copy that over here. And we'll keep in mind that we're going to use this expression in step 2. Okay, step 2 tells you to substitute that expression that we just put in the blue box into the other equation. So if the first equation is blue, then the other equation is the red one. So that means all I have to do is copy the other equation. Okay? And then what I taught you guys to do is look at the variable that's isolated, right? In this case, it's y. And we're going to change that one into a blank parentheses in this equation over here. So I'm going to put a blank parentheses there. And we say equals negative 7x minus 9. Okay? Now the thing that I'm going to plug in there is going to be what y is equal to. And y is equal to 7x plus 5. So we're going to go plug that in right here. Okay? So we have 7x plus 5. Okay? So now I just want you guys to see how all of these steps are exactly the same. Okay? Anytime we're doing substitution, we can follow this. Okay? We did do some extra steps here though, okay, because now I hope you realize, well, we can get rid of these parentheses because there's nothing on the outside, there's nothing multiplying, so the very next step that we would do would just be to drop the parentheses. And this is why I think a lot of my students already figured out that those first few steps were kind of like a waste of time, because we know that both of these are equal to y, and so that means they have to be equal to each other, right? So that's why we're able to get this thing from the blue box being equal to the thing in the red box, okay? Because they're both equal to y, and so they must be equal to each other. So a lot of students already jump straight to this step, all right, but I can't help but emphasize how all of these problems are really the same. So now what I would do is try to have you guys decide how to solve the equation, right? We're now done with step 2, okay? We've substituted. Step 3 says to do the distributive property. But because there's no number outside to distribute, right, I don't have to do my multiplications because there's no number right here, right? There's nothing there. So we just get rid of the parentheses, okay? Another way to think about it is it's like if it was an invisible 1 or something, okay? So to distribute the 1 just means to keep everything the same. Nothing changes, right? Now what we're going to do is add 7x to both sides. Okay, by adding 7x to both sides, that's going to give us the elimination of this variable right here. That goes away, right? And all that we have left on the right side is negative 9. But on the left side of this equation, we have 7x plus 7x, and that gives me 14x plus 5. So now what should happen? Okay, we should probably subtract 5 from both sides. And what's that going to give me? 14x equals negative 14. We go divide both sides by 14, and then we'll end up with x equals negative 1. Again, don't forget these 14s cancel out, right? And negative divided by a positive is a negative. So we got negative 1 right here, okay? So this value, what we need to do now is go plug that in for our x value. So we're going to go right here. We got 7x plus 5, and the number that goes inside there is what x is equal to, right? X is equal to negative 1, so we'll plug that in there. 7 times negative 1 is negative 7. And so if we make that negative 7 plus 5, we should see that our y value is negative 2. Okay, so for this problem, we've solved it, and we have our equation being negative 1, negative 2 is the solution to the system. Okay? You can always go plug in your numbers to check to see if they do what you wanted them to do, right? If they don't do what you wanted to do, then that's a problem, right? They need to make both of the equations true. So what I could do is I could go check them, right? Let's see if they make this one true. Is it true that they make this equation, the red equation, true? Let's go see. Well, if I plug in my number, we see y is equal to negative 2. So let's see, is it true that negative 2, right? Again, is it true that negative 2 is equal to negative 7 times x minus 9? Well, what's our x? Our x is negative 1. Let's go see if that's true. Is it true that negative 2 is equal to negative 7 minus 1? Is that true? Negative 7 minus 1 is 7, right? Minus 9. What's 7 minus 9? Is that negative 2? Yes, it's true that negative 2 is equal to negative 2. Okay, so I'm hoping you see that, yeah, these numbers, x and y, they make the red equation true. Okay, we can go check to see if they make the blue equation true also. Okay, and to do that, is to copy the blue equation. Okay, we got y equals 7x plus 5. And you guys can do this in your head occasionally, right? Every now and then it's good to write it down, but sometimes the numbers will be so easy you can do it in your head. Okay, our y value is negative 2. Okay, and then we're going to trade x for a blank parentheses, and the value that I plug in there is negative 1. So let's do that. Is it true that negative 2 is equal to negative 7 plus 5? Well, negative 7 plus 5 is equal to negative 2, and negative 2 is equal to negative 2. That's true. Okay, so look, it made both of these equations true. And so that means we found the right answer. And we can move on, and we know that our math worked out right. Okay, so let's move on to number 2. Okay, we did number 2 in class. And this one, I'll still do in the video, but this would be maybe a good time for you to skip over and fast forward. If you already have this problem done, there's no reason to watch it. Okay, so this video is here for everybody that maybe missed class today or something and needs to review. Maybe they weren't totally focused. I hope this can help you out a little bit then. Okay, so which one should I do to isolate the variable? Again, we're at step 1, isolate the variable. We learned that it would be best to use the red one here because we have a coefficient of 1. So what I want to do is isolate the x, so that means I want to move the 3y to the other side so that we can see the x by itself. So by doing that, we now get 3y minus 1. Okay, we'll put that in the box, and we'll come back to use that in step 2 and step 3. All right, so the more that you do examples of substitution, the more used to it you'll be. We copied the red equation, right? So we have to substitute into the other equation. So again, that means to copy the other equation then. Now what's going to happen is we go to the x, the variable that we isolated, and we turn that into a blank parentheses. Now over here, I'm going to go write negative 8 equals negative 23. And we want to take very careful, attention to each detail. Like, did we get all the negative signs? So double check when you copy to make sure everything's good. It looks like we did okay. Now I taught you guys to copy this twice so that we could then go plug that in here. And the reason why we're doing that is because I want you to imagine that we would have wrote it here. If we wrote it here, I want to say that maybe 30% of my students would have looked at their notes and they wouldn't have known what came first. Did the blank come first or did the red part come first? Well, now I hope you guys can see, right? The blank comes first, and then you go plug the number in. So I'm hoping that helps you out, okay? The next thing that we do is we apply step 3, the distributive property, okay? So I'm going to do negative 8 times positive 3, and that's going to give me negative 24 times y. Then we get negative 8 times negative 1. A negative times a negative gives you a positive. Okay, so now we got negative 7y equals negative 23. Okay, what we want to do is combine the y's, okay? So negative 24 minus 7, okay? So I hope you guys know, like, negative 24 minus 7 is equal to negative 31, okay? It's just looking at the number line. So because we have negative 24y and negative 7y, we have to have negative 31y. okay? And then plus 8. That 8 doesn't change, that stays right there still. Okay, so now to finish this up, what we want to do is start to simplify it, okay? This is a two-step equation. And I hope you guys know by now what a two-step equation is when you see it. Alright, so what we're going to do is take 8 from both sides. Minus 8. And we got this right here. Okay, divide both sides by negative 31. And there we go. We have a value for y. Okay, so we've solved that, but we're not done. Okay, that's just getting up to step 4. Now the last step, step 5, we want to remember to go plug that into this expression over here, and then we'll get our value. Okay, and in this case, the number that we pop in there is 1. Well, 3 times 1 is 3, and 3 minus 1 gives me 2. So now we have our final answer for this example. Okay, and we get x equals 2, y equals 1, okay? And so they go in a specific order. Don't forget the ordered pair, right? When we put in numbers in parentheses like that, the first one's always x and the next one is y, right? So we would then write is the solution to the system. All right? Those numbers will make the red equation true and the blue equation true. Okay, now we're going to get to the hardest problem. So those two were kind of like training mode for this one. Let's see what happens. Okay, there's a lot of steps that go into this one. Step 1 itself is already broken down into a lot of sub-steps. So we have the blue one, and we have the red one. Okay, so the new thing that's going to happen is we have to pick one. We have to pick one to isolate. So I'm just going to go ahead and work with the blue one. It doesn't matter which one we pick. In this case, I just happen to pick this one. All right. We want to isolate a variable. Okay, so I'm going to choose to isolate x, but you have to do this on purpose. You can't just accidentally isolate one. Okay, so pick the one that you want to isolate. In this case, I want to isolate x. So this is what I'll do. What I'm going to do is take 7y from both sides. After I take 7y from both sides, it's going to leave me with 5x on the left. And on the right side, we have negative 7y minus 10. Okay, the next thing that we're going to do now is realize that we're pretty close to solving this equation for x. I just have to divide both sides by 5. Okay, but that's going to give us something that's almost ready. All right, this is still have to be simplified. So we're not really done. Okay, there's going to be 2 more steps left. What we want to do is break this down to negative 7 over 5 times y, and then minus 10 over what? Check your understanding. What number am I to write underneath there? Okay, the number is a 5, right? Again, because we have 2 things on top of a fraction, they're both going to get broken up over 5. So we can simplify this. This fraction can't get broken down. But what about the other fraction? What about 10 over 5? All right, 10 divided by 5 is 2. Okay, so negative 10 over 5 is then minus 2. So we have this expression right here, and this is all we need so that we can get through this. Okay, so the next thing we're going to do is copy the other equation. So we got negative 5x minus 5y equals 10. Because we isolated x, I'm going to change the x into a blank parenthesis and leave the y alone. So we put our blank parentheses there and copy everything else. Okay, we did that twice. Okay, now the expression that's going to go in there is going to be this 7/5 y minus 2. So we're going to go put that right here, negative 7/5 y minus 2. Okay, so now we're going to calculate. What's going to happen here is negative 5 times negative 7 is going to make 35 over 5. Negative 5 times negative 2 is going to make positive 10. All right, and we can't forget the y, so that's got to go right there too. All right, 35y plus 10. Now we got minus 5y equals 10. So we're done with step 3. The distributive property has been done, but we still have a little bit of simplification and things to do, and that's what happens when you get fractions. You got to do the baby steps, right? So 35 divided by 5 is 7, so we have 7y plus 10 minus 5y equals 10, okay? We want to combine the like terms. So the ones that are like terms here are the y's, 7y and 5y. We call those like terms because they are alike, right? They both have a y in them. So what we think that means then is that we have to do 7y minus 5y, okay? And by now you guys should know that that is 2y. If you're having trouble combining like terms, you definitely should say something to me about it so that we can work on that skill specifically. Okay, now if I go ahead and subtract 10 from both sides, you guys should know this is a two-step equation, right? So I'm going to take 10 from both sides and then divide by 2. So we should already know that before we do it. Okay, so we take the 10, and then we see that 2y is equal to 0 because 10 minus 10 is 0. And so therefore, y has to be equal to 0. Okay, the only number that you can multiply times another number that's not 0 and end up with 0 is 0. Okay, so we should be able to jump straight to this step. But I know some of you guys want to see maybe algebraically what we would write. Okay, so we'll just do this last little baby step. We're going to divide both sides by 2. Okay, but what does that really mean? It means half of 0. Well, what's half of nothing is still nothing. Okay, so we got that last detail done, and they're all there. To finish this up, what we want to do is now go over here and plug into this our value y, right? We're going to go in there and do negative 7 fifth y minus 2, all right? Well, our y value is 0. So we'll go plug in 0 right here, and we know 0 times anything is 0. So this is really just 0 minus 2, and 0 minus 2 is just negative 2. So we have our second value right here. We have that x equals negative 2, and y equals 0. And now number 3 is complete. All right, that was much more work than the first one, right? I think you guys noticed that. So at this point, we'll go look at the elimination problems and see what we have. So I hope substitution, if you need more practice with that, feel free to email me and I'll get you what I can. Or you can watch the video on substitution, and there's also plenty of other videos on this. So if you need even more examples, feel free to search through YouTube and find what you need. All right? We're going to move on to number 4 right now. In this problem, we have a level 1 elimination problem because we can immediately eliminate them by just adding them. Okay, so I hope you guys can see what would happen here. I need you guys to observe that these have opposite signs. We have a negative 3 and a positive 3. So you want to make the observation that those would eliminate each other if I add them up, right? Negative 3x plus 3x is 0x. And negative 6y plus 6y is 0y. And then on this side we have 2 plus negative 3. All right, 2 plus negative 3, if we think about that, what's 2 plus negative 3? Okay, this just means 2 minus 3, right? It means I have $2 and then I spend $3. Like, what does that mean? Okay, well, you can't have $2 and spend $3. That'd be negative $1, okay? So I think right here, you guys hopefully understand why we have a negative 1, okay? So be careful with the numbers. Whenever they get really close to 0, I notice my students have a tendency to make more mistakes. Okay, so be careful about that. Well, 0x plus 0 times y, on the left side all we have is 0. And we got 0 equals negative 1, and we know that that is false. Okay, so if we just did a bunch of algebra and ended up with something that's false, that must have been that along the way something was false. Okay, and if all of our steps were right, then that means that what was false was our first step, which was assuming that this system can be solved. Okay, this system has no solution, okay? The lines are parallel, and that's what that means. Okay, so keep in mind that idea. No solution will be something like this. If I start with an equation like x plus 1 equals x, look at that. This expression is ridiculous. It should be ridiculous to you. Think about it. This is telling me that you can add 1 to a number and that the number will not change. But that's the whole point of counting, right? So look at what happens. Look at how ridiculous this is. If I take x from both sides, right, on the right side I have 0, but on the left side I have 1. And this is false. So you see what I mean? it was true that we could take x from both sides. That's possible. But what was the false part of it, it was this. This is never true, right? And that's really what we mean by something being false in math. You got me? So I really am trying to echo this idea of no solution. Okay, that means the lines were parallel and that we'll never find a place where they cross. Now I'll go take a look at 5. In this case, we see that we might be able to get away with subtracting. And that's because the 5x and the 5x have the same sign. You notice that? So if I put a minus right here, I could do this problem this way. Okay, I could say 5x minus 5x is 0x. And then 5y minus 10y, well, that's negative 15y. That's negative 5y minus 10y, so that's negative 15y. And then 30 minus 0 is 30. Okay, so if you notice, we were talking a lot today about how this is kind of extra work to be writing a 0x. Since it's 0x, it can go away, and we don't have to write it. And then in this step, I could wrap up really quick. I could divide both sides by negative 15. Okay, so here we get a y. But on the right side, 30 divided by negative 15 is going to give me negative 2. And so we're already moving pretty quickly. However, I didn't teach you guys to do it that way. All right? What I showed my students to do. Okay? If you understand what I just showed you, that's fine. You can do that. Maybe you'll be successful with that. All right? But I'm nervous about you guys doing that way. I'd rather have you guys change it into an addition problem. So what I taught you guys to do is when we see subtraction, we want to make it addition anyway. So I taught you guys is that a negative sign outside of a parentheses just means to change the sign of everything on the inside. So here the positive 5x will become negative 5x. The positive 10y will become negative 10y. And the 0 will become negative 0, but that's just 0, so we don't worry about that. Okay, and then on the top, I'm just going to copy that same equation because we already have what we want. So now I'm going to add this little bar underneath so we could do our addition. Notice, okay, we had a subtraction problem and we made it into an addition problem. The 5x minus the 5x is going to give me 0x, so I won't bother writing anything. Here, we got negative 15y, and then 30 plus 0 is just 30. We could divide both sides by negative 15. You see, we get the same number that we had anyway. But if all 100% of you guys go this way, I know more of you guys will get the right answer. So I can't help but try to, get more of you guys over the line. So think about that, okay? The next step that you would do would be to go plug in our y value into one of these expressions so that we can find what the x coordinate would have to be of these places where the lines cross, right? So I could take my y coordinate, put it over there, and all I have to do is copy one of these expressions. We'll start with the red one. Doesn't matter which one I copy, the red one or the blue one up here, right? If this is the blue one, I could copy that one. Sorry, if this is the blue one, I could copy that one, or I could copy the one in red. It doesn't matter, okay? But when I copy it, I have to go plug in this number for y, and then I have to solve to figure out what x is. So I'm only going to change the y into a blank parentheses, and then what goes in there is negative 2. So now we're going to get 5x, negative 5 times negative 2 makes positive 10, and then we get 30 right here. And so now what's going to happen is if I see this two-step equation, I'm going to have to take 10 from both sides, and taking 10 from both sides is going to give me 5x equals 20. And then 5x plus 20, 5x equals 20, I'm going to divide both sides by 5. And then we'll have the x is equal to 4. And so we get the second coordinate, and we're good. So we have x equals 4, y equals negative 2 is the solution to the system of equations. And then you guys can move on to the next problem. Okay, so now for number 6, we have another system of elimination. And in this one, it looks like we only have to multiply one of these equations. So don't forget these problems get progressively harder. And the good news is that you should know how they're going to get harder, so you should know exactly what you're going to have to do every time. So I really am trying to focus on you guys being familiar with this. Is there any number I could eliminate? Which letter, right, which variable would be the easiest to eliminate? Is there any way I could turn that negative 2 into a negative 12? Because if I could do that, then I'd be able to add these equations and eliminate and move on. Well, I think the number that comes to mind is 6, right? 6 times negative 2 gives me negative 12. So let's go ahead and multiply this whole equation everything, all three of those, by 6. Okay, so first off, we got this little arrow to show the new equation that's going to result, and we'll get negative 12x. Okay, but then 6 times positive 2y is going to give me positive 12y, and then 6 times negative 2 is going to give me negative 12. And so on top, I just have to copy that same equation, because again, the whole purpose of doing this is based on this idea that you guys would have observed, right? That you would have seen that I can eliminate a variable by adding them together now. And that's why we didn't have to change this one up here, okay? This one didn't change. We wanted to change this number to look like that number. So that's why I don't want it to change also. So I only have to change one of them. And this is like a level 2 problem, we were calling it, right? Where we only have to multiply one of the rows, okay? So we need to add these, right? We're going to add them up. 12x minus 12x gives me 0x, okay? Negative 12y plus 12y gives me 0y, okay? So on the left side, we can see we have 0 again, right? And on the right side, look at this though. 12 plus negative 12, that means 12 minus 12, and that means 0. And 0 is equal to 0. So this time we're not going to say false, okay? And the lines aren't parallel, but they have the same slope. And that's because both of these lines are actually the same line. These two lines are right on top of each other. Okay, so in this case we say infinitely many solutions. Okay, and if I was to go do this on Desmos right now and graph these two lines in different colors, you would see that they land right on top of each other. Okay, so infinitely many solutions. Let's go see what that comes from algebraically. Alright, so this is the opposite of what I said earlier. What if we start with an equation that's just always true? What if I write x plus 1 equals x plus 1? I mean, it's definitely true. We have the same thing on both sides, right? But what if I take away x from both sides? Okay, then I just get 1 equals 1. And what if I take away 1 from both sides? Then I get 0 equals 0, okay? So in algebra, we call this an identity. Alright, an identity is what we call it, and that's what it is. When you start with something that was the same on both sides of an equation, okay? We just end up with 0 equals 0, and it has infinitely many solutions technically, because every single number that is on the left would also be on the right, okay? So there we go, number 6 is complete. That was kind of good that we had that situation covered. Now that special case of infinitely many solutions and no solution, we covered those. So now we get to the level 3 elimination problems, where you have to multiply both of them. Okay, we learned about the least common multiple, and that's actually less important than this concept of what I want them to be, right? So it doesn't necessarily matter that you use the least common multiple. That's just maybe the simplest way to do it, all right? The idea that I really want to instill in you guys is that I want to turn these equations, right, into something where the coefficients of the x's are opposites of each other, right? So this would be like 6 and negative 6, or I would want the y's to be opposites of each other, like negative 2 and positive 2, okay? So we're going to think to ourselves, is there anything I can multiply a 4 by, like an integer, that I can multiply it by that would then give me a 6? All right, the answer is no, there's nothing. And the same thing for 5. What can I multiply a 5 by to give me a 2? There's nothing either, okay? So we want to think about what would be another strategy. I'm going to have to multiply both of them to something, okay? Let's choose which variable we want to eliminate. We want to do this on purpose, okay? Let's say we want to eliminate the x. So that means I want to find the least common multiple of 4 and 6. Okay? Well, let's look at what those look like, right? We got 4, 8, 12. All right, what are the multiples of 6? We got 6 and then 12. Look, we already round into one that they have in common. 6 times 2 is 12, and 4 times 3 is 12. So what that means is that if I multiply this one by 3, I'll get 12. And if I multiply this one by 2, I will get 12. Okay? But most importantly, look at what's actually going to happen. Because we have a negative 3 right there, a negative 4, I mean, this one is going to turn into a negative 12x, right, when I do this times that. Okay? But also, the 2 times the 6x is going to give me a positive 12x, and those will be able to eliminate each other. So now I'm just going to finish up the multiplication. We do 2 times the negative 2, and that's going to give me positive 4y, sorry, negative 4y. Okay, and then we got equals 2 times 24, and that gives me 48, so that number increased a little bit. And now we get the next one. We did 3 times negative 4, and now we do 3 times 5, which is 15. So we have 15y, and then we do 3 times 27, which is 60, plus 21, and we'll make it negative, so we get negative 81. Okay, now what can we do? I'm hoping you guys observed that we set this up on purpose. And that's the one thing about elimination, is you have to do some planning. You have to have some foresight and see what's going to happen in the future and make it happen according to the way you wanted it to happen. Okay, so look at what we did. We set this up on purpose because we wanted there to be 0x. We just eliminated the x, right? Negative 4y plus 15y is going to give us 11y. And if we look at this other value, I got to do 48 plus 81. Okay, so we add these two up. And we're looking for something to be a multiple of 11. So like I've been telling you guys, we might feel a little nervous until we see, hey, we got negative 33. Okay, and that is a multiple of 11. And like I was telling you guys, look, the 0x is really just, you know, kind of making us go slower. So let's erase it. And now what I want to do is just divide both sides by what to solve it? Just divide both sides by 11. Okay, well, y is equal to negative 3. Okay, now we go plug that into any one of the other equations to solve for the second coordinate. And we've done that a lot. I don't want this video to run on too much, but I guess I might as well at least start the process and let you guys finish it. Okay, so then we would pick one of these equations. Let's say I pick the top one. So 6x minus 2y equals 24. Okay, well, what number goes in there? Okay, well, the number that I'm going to plug in here is negative 3. So we got 6x plus 6, right? Because negative 2 times negative 3 is 6. And then we got 24 right here. So what if I go ahead and take 6 from both sides? I'm going to get 6x equals 18. Divide both sides by 6. You get x equals 3. Okay, so we have an answer for this one too. Again, don't forget to represent your answers as ordered pairs. Okay, and then tell me, is the solution to the system? I'm not going to write it so the video can run through, but you guys should definitely be writing that whole sentence right there. All right, the next thing we're going to go do is the word problem. Okay, now I won't solve the whole problem. You guys could do that by elimination, I believe, on this one, and like multiply some things together. So I'll probably give you the roadmap, but I won't solve the whole problem so this video can kind of finally run on, okay, and be done and be online. So this equation and this equation, okay, we're going to learn how to do that. The most important part is first that you write down which variable is going to take track of what, okay? And we should also read the question. So if we look at this, it says the school that Brenda goes to is selling tickets to the talent show. And on the first day of ticket sales, the school sold 3 adult tickets and 9 child tickets for a total of 66. That's on the first day, all right? But on the second day, so that's going to give us a second equation, they made $92, so they made more money, and they sold more tickets. So what we want to know is what is the price of 1 adult ticket and 1 child ticket. That's our idea, okay? So what we need to understand here is that I'm going to make X the price of the adult ticket, okay? And then for Y, we'll make that the price of the child ticket. Okay, and that's kind of the whole point of variables, is that we use them to stand for kind of anything, any amount. So in this case, we can use X and Y. We could use any other letter, but we've been so used to using X and Y, why would we change now, right? So the equation that we want to get out of the red one, okay, like I was telling everybody today in class, we have this X plus Y equals something, okay? And basically it says that in the red equation, they have to equal to 66 when we add these up, okay? But it says we sold 3 adult tickets, and X is the price of the adult ticket, and we sold 3 of them. So that means that we would get 3 times X. That's how much dollars we would make, okay? And then if I sold 9 child tickets, then Y is the price of the ticket. Then it would be 9 tickets times the price of a ticket, and that's how much money that would make, right? So if we add those up, that gives us our total, okay? And total is very important that we understand that that means that we're supposed to add these up. Okay, now for the blue equation, you guys might want to check your own understanding. What am I going to write? We should have 92 on the right, and on the left-hand side, we should have 11x plus 3y because there's only 3 child tickets that time. Okay, now to solve this thing, we have a couple choices to make. And do we want to use elimination or substitution? Okay, I hope you guys realize that we want to use elimination. Okay, what can I multiply this equation by so that I would be able to eliminate one of these variables? Okay, so is it easy to turn an 11 into a 3 or a 3 into 11? Can I do that with the integer? Okay, I don't think so. Can I turn the 3 into a 9 though? Okay, well that's doable, right? So if I multiply this whole thing by 3, I would end up getting a positive 9. So I want to get a negative 9, right? Because we want to eliminate. So in that case, I'm going to use a negative 3. So let's see what that does when we distribute that 3 to everything up here, all right? The first thing we'll get is negative 33x. Then we do 3 times the 3y, and that's going to give me plus 9y. And then I do have to do 3 all the way times this one, right? Times 92, and that's going to be a negative. Oh, and it looks like I forgot to change the sign of this one, right? So again, negative 3. I usually say this out loud to make sure I don't mess it up. Negative 3 times positive 3, that would give me negative 9. Okay, so I kind of recommend talking out loud to yourself a little bit to help you get through this. Sometimes for me, at least hearing it helps you do it the right way. Okay, I'm an auditory learner, so you have to know what kind of learner you are. That'll help you out. Negative 3 times positive 92 is a negative. Okay, we got negative 276. And so we can see that we have the other equation on top. We got 3x plus 9y equals 66, okay? And now that we have opposite signs, we can eliminate our variables, right? 3x minus 33x, that's going to give me minus 30x, right? Okay? But the 9y minus 9y is going to give me 0y, okay? And that's why I was telling you guys today, we're going to stop writing the 0y so much because it's kind of just a waste of time once you know that it's eliminated. It's gone. That's the whole point of eliminating it. At some point, we're going to make it disappear. So it's up to you. If you want to write an extra step, you can go ahead and do that, but I kind of recommend you don't. Okay? Negative 276 plus 66, or basically positive 66 minus 276 is going to give us negative 210. And if we divide both sides by 30, well, I'll let you guys finish that on your own. Okay? Just don't forget that we'd have to find our number and plug it back into the equation so that we can figure out what the child price is. Okay, we did this problem in class, so I'm not that worried about it. You guys should be able to wrap it up. The hardest part was really probably writing the equation because you guys hadn't seen this so many times. Okay, the last one right here was to solve the system by graphing. We went over a way to do this in class where you guys would basically put the two XY coordinates, the intercepts, together. Okay, so first of all, to solve this one, you want to have our solution. Okay, so let's go ahead and take a look at what we had here. The solution, the point where the lines cross, is at negative 1 and positive 2. And that's the solution here. But you don't only want to solve this by graphing. Okay, today we learned after we solve it by graphing, we wanted to write and then solve it by substitution or elimination. Okay, well, which one would we want to solve this by right now? Okay, well, I'm hoping you guys could look at that and realize that, wait a minute, we got this whole idea right here. I can just add them right now because the y's have opposite signs. So I'm hoping you would have keyed in on this idea, right? That elimination, we want that opposite sign. So 2x plus 4x is 6x. Negative y plus y is just 0 because we eliminated it. And negative 4 plus negative 2 is negative 6. So we're going to be done really quick here. If I divide both sides by 6, we'll get x equals negative 1. And then I just have to go plug that into one of those equations like we've been doing, right? Okay, if I plug it into this one, we'll be able to get an answer. Okay, we do 2, and because I'm substituting for x, right, that is now the blank parentheses. And we want to figure out what the y is. So the negative 1 goes in here, and that gives me negative 2 minus y equals negative 4. And that's a two-step equation. Okay, I'm going to add 2 to both sides, right? And then we're going to divide by negative 1. So adding 2 gives me that negative y equals negative 2. And now just divide both sides by negative 1. And we're going to get that y equals 2. And so our last answer on this test is the solution to the system. All right, blah, blah, blah. All right, anyway, you guys get my point. This video went a little longer than I wanted it to be, so I'm going to stop it here. If you do need to review graphing standard form lines, you might want to go back and watch one of those videos because I know I did that part a little quickly. Okay, so go back and watch the video about graphing standard form. That's all you really need, okay? Good luck with this test, everybody.